A disappointing superconductor update. Contact re-established with Voyager 2. Two stars orbiting so closely they could hide inside the sun. And a field of gravitational lenses in a new JWST image. All this and more in this week's Space Bites. Last week we talked about the potential for a room temperature, room pressure superconductor called LK-99. And this was published unannounced by a team of Korean researchers, and material scientists around the world were studying the results. They were trying to replicate the results, and now we're a week later and we've got a lot more information about whether or not this is actually a superconductor. And so far, the news doesn't look good. People haven't been able to replicate or improve on it as a superconductor. There's been other explanations for some of the other effects that people have seen. Just to reiterate, if something is claimed to be a superconductor, when you measure the voltage across the material, you need to get a 0 voltage drop. You need to measure no resistance across the material. And also, if a small enough piece is put above a magnet, it needs to be able to float in this very special way that's called flux pinning, or the Meissner effect. And with the initial paper, researchers already pointed out that the way the resistance was dropping, the way the voltage drop was happening, didn't exactly match the way a superconductor should. And now with enough replications, scientists are starting to believe that what was causing this levitation was iron particles that are suspended inside the material that are enough for it to float next to a magnet. And a partial drop in resistance that was seen can be explained by the presence of copper sulfide. At this point, I would say things don't look good. Last week I was skeptical. This week I'm pessimistic about whether or not this is going to turn out to be a room temperature, room pressure superconductor. But this is how science works. Somebody makes a claim, other people attempt to replicate the claim. If they're unable to replicate it, if they're unable to show that this is true, then nobody will take the claim seriously. So I'll let you know if there are any more updates to this superconductor story. Maybe someone is going to amazingly replicate it and demonstrate that it is indeed a superconductor, but I wouldn't raise your hopes at this point. Yeah, I mean, there's lots of interesting material science out there that could be done that we will stumble into, and some will have interesting uses. But there was some good news in the future power department, and this was that the National Ignition Facility achieved positive net fusion again in their experiment. Just keep in mind, this is laser ignition fusion, where they have a small piece of deuterium fuel. They fire at it with a whole bunch of lasers. They're able to fuse power out of the fuel, and they're able to produce more power from the fuel than the amount of energy that went in from the lasers. But that's just like shooting the fuel with the lasers, and not all of the setup and all of the additional capacitors that were required to get the whole system up and operational. So this isn't going to provide our base load fusion power, but it's going to help us understand more about how fusion works. We didn't get the exact amount of energy that was released. We just heard that they had replicated it, that they had been more efficient than last time. We're still waiting for the National Ignition Facility to release the results. And this is just a quick version. If you want more information, we actually did a whole video all about the fusion breakthrough a few months ago, so here's a link to that. Last week we reported that NASA had lost contact with Voyager 2, that there had been a command sent to the spacecraft to change the orientation of its antenna, and it put it out of alignment with Earth, and so they weren't able to send any communications back and forth from the spacecraft, and they were going to have to wait until October for it to reset and reacquire its signal. But they were able to detect that the spacecraft was still there. They were able to detect a heartbeat of the spacecraft, and NASA was able to reconnect with the spacecraft. They sent what they called an interstellar shout, a very powerful blast of radio waves, a message shouting out to Voyager to turn its orientation and point back at Earth. And amazingly, the spacecraft did receive the signal, receive the new commands, change its orientation, and contact was reestablished. What's amazing about this is that the Voyager 2 spacecraft is so far away from Earth that it takes 37 hours for a return message to go to and from Voyager. But with the established communication, they're able to confirm that everything is working great. They're still getting telemetry and science information, and no need to wait for that reestablished communication in October. More rovers going to the moon. All eyes are on the moon, and especially the south pole of the moon, because this is where NASA is going to be sending the crew of the Artemis 3 mission. They're going to set foot near the moon's south pole, which is such an exciting place because we know that there are deposits of water ice down at the south pole. And this is a place where future missions can go and acquire water and be able to provide propellant and air for astronauts. There's all kinds of reasons you want to get water from the surface of the moon. But before the humans go, NASA is going to be sending a bunch of robotic missions. And one of the missions that's in the works is called the Cooperative Autonomous Distributed Robotic Exploration, or CADRE. And this is 3 suitcase-sized rovers that are designed to work autonomously from Earth, but to be able to work together as a team. The rovers will travel as like a wolf pack across the terrain. They'll be communicating back and forth with each other, identifying hazards across the terrain, and they'll be trying to map a region on the surface of the moon that's about 400 square meters. And they'll send all of this detailed information back to Earth. They're only going to last for 1 lunar day, which is about 14 Earth days. And that's because you get sunlight on the moon for 1 day. And then the sun goes down, and then the temperatures plummet, and there's no power for their solar panels. And they're just not designed to handle that. But hopefully they'll get a ton of work done in that first 14 days. What's interesting about this mission is that the rovers are designed to make a lot of the decisions by themselves. So NASA controllers will tell them to go over and explore that region or map out this area, but they'll be making a lot of their decisions by themselves on what kinds of terrain to avoid, how to approach and map different regions on the moon as they get close to it. So it's a really interesting experiment and something that we could see farther places like on Mars, where the communications delays are so long that it just doesn't make sense to try and micromanage every movement by a rover. Speaking of the moon's south pole, India's Chandrayaan-3 mission has arrived at the moon and is now in the process of circularizing its orbit. So it's making a bunch of orbital maneuvers to bring it closer and closer to the surface of the moon. And on August 23rd, it's going to deploy a rover and a lander down to the surface of the moon. Once again, down to the south pole of the moon. And no spacecraft has ever made a soft landing near the south pole of the moon. And so if India is able to pull this off, they will be the first ones to start to explore this area in detail. And of course, all eyes are on India because with the Chandrayaan-2 mission, they had an unscheduled rapid disassembly. The Chandrayaan-2 lander crashed onto the moon, and so they weren't able to complete the mission as they'd hoped. Ingenuity had an unscheduled landing. Now, NASA's Mars helicopter just completed its 54th flight on the surface of Mars. 54 flights for this helicopter. It's amazing. But this flight was a little unusual because it was a very short hop designed to test out to make sure that the helicopter was working fine. And that's because on the previous flight, on flight 53, they ran into a problem with the helicopter that caused it to shorten its flight significantly. So they had a very ambitious plan for flight number 53. The helicopter was going to fly over to a rocky outcrop, was going to hover above it, was going to take fairly detailed observations, take a bunch of pictures, and then scientists would be able to use this to be able to direct the upcoming movements of the Perseverance rover. But it got about halfway to the outcrop when it triggered its land now function, which is sort of amazing that it has this. And it aborted the approach to the outcrop and just landed immediately on the surface of Mars. Now, NASA isn't entirely sure why it shortened its flight, but it's believed that it had something to do with the images that were coming in from its camera weren't syncing up with the internal inertial sensors on the helicopter, and just to be safe, it decided to cut the mission short and land. And so with flight 54, they took off again and just wanted to make sure that everything was working perfectly, that there wasn't any systemic problem with the helicopter. So with flight 54 out of the way, with the problem probably diagnosed, they should be able to be set to do even more operations. Like, are we going to get to flight 100, flight 200? This is amazing. And if you remember a couple of weeks ago, we talked about how they lost contact with the helicopter. And so now the operations have kept the helicopter and Perseverance pretty close to each other. And so we got a lot of really cool pictures. We've got pictures of Ingenuity from Perseverance, and we got pictures of Perseverance from Ingenuity. Two stars orbiting very close to each other. Astronomers have found a binary star system where the two stars are orbiting so closely that you could hide their orbits inside the sun. So one is a very low mass red dwarf star, an M dwarf, and the other is a very, very low mass, maybe a red dwarf, maybe a brown dwarf. It's like right on the edge. And so this brown dwarf is orbiting around the star every 1.9 hours. If you measure the size of the orbit, it could fit within the size of the sun. And this system is fairly strange, and astronomers aren't entirely sure how we got here, because we haven't seen very many of them out there across the universe. They believe that the two stars started their lives much farther apart, and then over time, the brown dwarf has orbited closer and closer to the star. There's a couple of mechanisms. So one thing is that stars lose mass over time. They just are sending off their stellar winds, and that causes both stars to lose mass, and that will cause their orbit to lower. Based on these movements, astronomers think it'll take about 1.3 billion years for the brown dwarf to cross the Roche limit around the star when the gravitational forces tear it apart, and then they'll merge, and who knows what'll happen at that point. The other possibility is that there's some kind of magnetic field that's interacting between the two stars. And if that's the case, then this braking system is actually happening a lot more quickly. And if that's the case, then the orbital period is going to shorten dramatically, and the stars will only remain in orbit for a few tens of millions of years before they collide. This is the kind of system that astronomers are hoping to be able to find many more examples of. And fortunately, there's a lot of next generation telescopes that are coming out. Maybe not Vera Rubin, but maybe. And so if they can find more examples of these, it can really help us understand how stars change in their orbits over time, how planets change in their orbits over time. What does the future hold as binary systems get closer and closer together? Every week, we do a vote on our community tab where we ask you to vote for what you thought was the best story of the week. And last week, the majority voted for this possible superconductor breakthrough. I wonder what's going to happen this week. We'll see how exciting you all find a null result. We're also doing the final JWST picture results. So we've been doing the quarterfinals, the semifinals, and now we're into the finals. We've got the 4 images that you have to choose which is the one you think is the best. And the vote is really close. And often the number 1 position has changed a couple of times. So every vote counts. So go ahead, when you see the vote show up in the community tab, go ahead and give us a vote if you haven't already, as well as for the stories this week. And you're most likely to see this vote if you're subscribed to the channel. So subscribe to the channel if you haven't already. JWST sees multiple gravitational lenses. We got a new picture from JWST this week, and this is of a massive galaxy cluster seen about 6.8 billion years ago, taken from JWST. The cluster is nicknamed El Gordo, which means the fat one, and it is just an enormous galaxy cluster with hundreds of galaxies all coming together. And from all of this intense gravity, you've got a bunch of gravitational lenses in this image. Of course, this is where the gravity is acting like a natural telescope lens for galaxies that are much farther behind. One is nicknamed the fishhook, and the light has been traveling for 10.6 billion years to reach our eyes, and it's gone through this gravitational lens. And the other one is called the thin one, and it's seen at 11 billion years ago. And one kind of amazing thing is that there's actually a single red dwarf star. We can't see any red dwarf stars with the unaided eye. It takes a telescope to be able to see them out to a few light years. We've never seen one beyond a billion light years with a telescope, and yet you can see a single red dwarf star in one of these galaxies thanks to the gravitational lens. It's time to see some Perseid meteors. Every year, around August 13th, we get a chance to see the Perseid meteor shower. This is when the Earth passes through the dust trail from a comet and the number of meteors that you can see in the sky rises. The Perseids aren't the best meteor shower of the year, like probably the Geminids is the one that gives you the most meteors every year, but for those of us in the Northern Hemisphere, it's the best one because the nights are warm, and so you can sit outside under the stars and watch for meteors. And you can see about a meteor a minute or so, 60 an hour under nice conditions. This year is the perfect year because we've got a new moon on August the 16th. So just a couple of days after the meteor shower peaks. And so you're not going to get that light pollution from the moon, and you're going to be able to see some of the fainter meteor trails as they go across the sky. Now, don't panic if you've got cloudy skies on the 13th. Like, the shower builds a couple of days before and a few days after. So the 13th is the peak, but you can still see a lot of meteors on the 12th or on the 14th. So if you've got dark skies, gather your friends together, spend some time outside looking up in the darkest skies that you can get your hands on, and you don't have to worry about the moon. So this is a really good year, one of the best years that we've had in quite a while to be able to see the Perseid meteors. And finally, a super heavy hot fire test. This week, SpaceX shared a hot fire test of Booster 9, which is another one of the super heavy boosters. So the big thing that they were testing this week was the water diversion system. So if you remember on the previous launch, there was no flame suppression system underneath the rocket. It took off, it excavated a bunch of concrete, dust was falling around the landscape on a nearby town, hit cars. It was a rough takeoff. So now they've got this huge steel plate. They've got an enormous amount of water that they pump in to try and cool down and minimize the acoustic vibrations from the rocket launch. They didn't launch the booster, but they fired it for duration. They fired it for 2.7 seconds at partial throttle, the kind of thing that you would see as the rocket is taking off. It's still too early to know exactly what happened, but I mean, we didn't see any damage. We could see the water suppression system pouring enormous amounts of water in underneath the rocket. During the test, we got an announcement that 4 of its engines shut off prematurely. So I'm sure they're going to look into that. So another test. We don't know how and when this is going to lead into the next full stack test of SuperHeavy and Starship, but progress is continuing. And if you're interested in what you could do with Starship, we've got a new interview that I had with Dr. Daniel Apai, who is the project manager for the Nautilus telescope. This is a space telescope where you could launch, say, 15 identical telescopes inside a single Starship fairing. And hopefully, if we get Starship successfully launching, a lot of really interesting telescopes and missions come online after that. In fact, I'm going to talk a little bit more about the possibilities of Starship in a second, but first I want to thank our patrons who support us at the Master of the Universe level. Thanks to Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Shiplin, Jay Dennis, David Giltonan, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbeoff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. So I think when people talk about Starship, they're quite excited about the possibility of like colonizing Mars, about sending humans to Mars. And I don't know. I mean, I think Mars is a lot harder to live on than people are expecting. It's kind of like Antarctica, except you can't breathe and there's radiation and there's low gravity and you're gonna have to live underground. But if we could get a super heavy lift vehicle like this, especially if it's reusable, even if it's not reusable, a lot of really interesting missions become available. There's a lot of stuff where astronomers have some kind of space telescope concept that they want to do, but it would be too heavy, too big to fit inside a fairing. And we saw what happened with James Webb Space Telescope, right? They had to minimize the weight and the size of every single part of that telescope just to make it fit within the 5-meter Ariane 5 fairing. If you get to this point where you can make these telescopes fit easily within a much larger 9-meter fairing, then it simplifies the development of your telescope. You can have heavier telescope, and like the heavier it is, the less work you have to put into minimizing the weight. And actually, like, our imagination hasn't really caught up with the capability of a super heavy lift vehicle like this. So if and when Starship does launch, we're going to see it quickly gulp down all of the existing missions that are on the books right now, a lot of the ideas that we're waiting for some kind of super heavy, inexpensive, super heavy lift vehicle, they'll be able to fly on Starship. But the part that I'm really excited about is like, what is possible? What missions could be designed where they depend on a super heavy lift vehicle with a relatively low launch cost in a 9-meter fairing that spacecraft can be reused in orbit and then fly to other places? Like, we don't even know what's possible with science with that kind of a flight platform. So I really do hope that Starship flies, and if not Starship, then whatever comes next from any of the other heavy lift vehicles. It would be great to have a fully reusable 2-stage rocket system to be able to get some of this science back.